Okay, so the title, long enough for a 15-second slide, is Automated Interactive 3D Geospatial Data Assimilation, Formatting, and Visualization System for developing subsurface conceptual site models. So really what this was a massive geospatial data scraping, assimilation, munging, and transformation and visualization project. This is the team: Aaron, petroleum engineer; Bruce is a software developer; myself, and my background is geology. And then our advisor was a gentleman from industry named John Carney. He's in the petroleum and also a software developer. Cool. So just by way of introduction, the ability to demonstrate complex subsurface geospatial data is fundamental in earth science consulting. 3D subsurface conceptual site models. A 3D visualization can actually become the conceptual site model if it's comprehensive enough. Seeing data in their true geospatial context is a powerful way to describe, understand, and communicate data. And geospatial data availability has exploded with online government databases. More data is more readily available to be visualized than ever before. Data sets are ever expanding, and it's readily available. But with that comes a caveat, especially when it comes to Texas data. It's been assimilated, but not in such a way that oil and gas data, injection data, and groundwater data they're all in separate places and separate databases stored in different ways with their own standards and data formats, different key identifiers, and different coordinate projections. So it can take a long time to bring them all together to map them. And there's consequences to this. So if you don't understand the data, bad things can happen. This is just one example. And I like that quote there: the Texas Railroad Commission has no information. It's a black hole. And this is talking about groundwater contamination because they don't know where the injection wells are in relation to the aquifer data in Texas. In addition to this, the companies that have traditionally been thought of as the ones to bring all this data together, honestly, there's two of them, and they've grown so big that now their licenses are tens of thousands of dollars. They've just kind of come prohibited for the general consumer working at their desk. And so our solution to this is kind of like a Google Earth for the subsurface. It's a system that gets all of this data, visualizes it from free and publicly available databases, and produces interactive 3D visualizations on demand without the need for the end user to have any software licenses. And from here on after, I just refer to this thing that we built as the product. This is kind of the basic flowchart of what the product is. There's user input, which is very simple. It's 4 coordinates. It's a bounding box. And then the product goes to the government website. It scrapes the websites for the data in those bounding boxes, formats them, assimilates them, visualizes them, and delivers them back with the database and the visualizations. We needed a visualization system to do this. The one that we chose was CTEK's Earth Volumetric Studio. It's a commercial software that it's a very powerful visualization system, 3D visualization system. It has a fully integrated earth science toolkit, and the 3D visualizations can be deployed without licenses. These are just some of the data formats that you have to get it in to make it work in EVS. I won't go into detail into these right now. Mostly ASCII files and vectors and rasters that you have to bring everything into, in same coordinate system. So here's step one. The first thing it does is it's depicted by the black box. So the user inputs the bounding box. Then the black box goes out and scrapes the web for the data in that bounding box from the USGS. Then the black box visualizes it in 3D. And this is the digital elevation model. Then it goes and gets the water data from the Texas Water Development Board data and visualizes all the water wells in there and all the attributes of the water wells and the aquifer services. And then it goes to the Railroad Commission and scrapes that for all of the oil and gas data and all of the underground injection control data and visualizes all that in the same visualizations. These are more than just pretty pictures. They're more than just kind of eye candy. They're also can be used to for permit application figures and things like this. And I put this in here because once we got it built, we're already getting to use this for some clients. So it's already becoming a valuable tool. So this is a quick movie of what it looks like. So that's the USGS DEM layers. And then in come the water wells from the Texas Water Development Board with the different attributes. And the aquifer surfaces also from the Texas Water Development Board, groundwater availability models. And those can be shown as surfaces or fully 3D volumetric models. And then the Railroad Commission underground injection control wells. So these are the wells that they're using to inject oil field waste into the subsurface. And we show how those relate to the aquifers. And then finally, the Railroad Commission formation tops. All kinds of geologic layers are in these databases that we bring in, and oil and gas wells, and there's hundreds and hundreds of thousands of these wells. And so that's above the hood. The next video shows it under the hood. So the next video shows it actually running. So this is it. This is it running, going out, scraping, getting everything. And so you're actually seeing it run, and then it automatically opens EVS and visualizes and delivers the visualizations. And then this is the last slide. This is what the end user gets. After he puts this in a bounding box, he gets this back. It's just a file with all his databases in it and his 3D models. And so that's it.
Well, I don't know about the data, but the visualizations are so cool. I mean, they're really cool, actually. Say EBS, is that what the tool that you said you use? What tool was that?
Yeah, Earth Volumetric Studio.
Yeah, this is very cool, man. I mean, it's really, very great job.
Mm.
Yeah. So, I mean, obviously your job, so what's your plan with this thing? Are you going to go back and give it to these companies, or what's the end goal that you had? I mean, there's a reason why you did this, obviously.
Yeah, it's just these databases, these repositories are something that Aaron and I have to deal with all the time in our work. And we spend weeks and days and weeks and months sometimes building these map models and maps. And so when we were talking about Capstone, we were like, we're just going to automate this whole thing. And now it takes it 4 minutes to run for, about a 50 by 50 square mile area.
Oh my God. That's very cool. Sorry, somebody has a question?
Yeah, I just wanted to add, I think that it was really amazing. The visualizations are just incredible. This is Alan, by the way. One of my partners, Brock, has a background in petroleum companies as well, and we had kind of envisioned a similar idea on this probably about 1.5 years ago, but you blew us out of the water, like way above and beyond whatever we had imagined. This is terrific. One of the things that we ran into, though, you talked about publicly available databases. One of the things that we ran into as we talked to different geological friends and colleagues and so forth was that there isn't a lot of publicly available data around subsurface. And I'm wondering how you overcame some of that. Or maybe you just knew of resources that maybe we did not know. But at least whenever we were digging into this, we ran into a lot of resistance because of the lack of publicly available data for a subsurface. Could you talk a little bit about how you got the data?
Yeah, sure. There's a ton. I can send you to the Railroad Commission website. It has every single oil well, all the production data, all the completion data. Yeah, and then the Texas Water Development Board has every single water well, and they have a groundwater database, 140,000 wells in that database, and then they have their GAM models. So all the data is there, and then the USGS has the framework for the visualization. So they have all the digital elevation models and all the aerial photos.
This whole thing went like way over my head. So can you just sum up for me real quick how this solves the problem that you're having?
Yeah, so if you want a 3D map of the subsurface, you're a developer, you put in wells, you just give it a bounding box. You just give the product a bounding box. You just say minimum latitude, maximum longitude, minimum, or, just give it a bounding box, hit run, and it goes, scrapes everything, visualizes it, and gives it back to you. So conceptually, it's very simple, but building it, not so much.
Okay, so sorry, I had quick two questions. Actually, they're related and they're just an extension to what Alan asked. So one is so suppose you have to scale this to something else. For example, now you're showing water and gas, and suppose you want to show some other attributes from the same surface area. So how you are going to scale that? That's one. And second is suppose we are okay, so a new source, and suppose we are not having anything in particular area. So how you handle that particular case? And is there any option for user to choose that he wants to select only a specific type of fields and not a specific type of attributes and not others? So they're just related. But
yeah, all geospatial data has the same basic format. It's X, Y, Z, and a value. So if you want to put your own custom proprietary data into the visualization and it's geospatial data, all you have to do is project it into the same coordinate system, and then you can visualize it in with the models and the other layers. The reason that we chose EVS was because it delivers visualizations that you need the license to build them, but you don't need them to distribute them. So that's why we chose that. So all the models that you get back, you don't need to buy a license. It comes on a free distributable player that you can share with whoever you want.
Okay, thank you.
Cool. Thank you, sir. And who is next? Shantanu.